Business FM.
There's been a lot of tech news in the last 10 days or so here in the UAE. We've covered much of it here on Mira Business FM. It's kind of that time of year, really. The juggernaut that is GITEX has taken centre stage. And as you would expect, quite rightly, there's been much chatter, more than a little, about AI, the latest in AI innovation, where it's being featured, where it's being deployed by companies, by corporates, and how it's going to change our lives. That's really the conversation at the moment. The question is, I think, just how great is artificial intelligence right now? That means time to talk to Nasser Bostan once again. Nasser is the founder of Simulacra X, which is a next-generation cognitive cybersecurity platform, and he is on the line. You're not in the studio this time. Nasser, you are in Vietnam, am I right?
Yeah, hi Tim. I am here in Ho Chi Minh City, just spending some time here, kind of doing a bit of a digital nomad thing, and also checking out some of the local technical resources that they have out here.
It's good to have you on, Nasser. It's always nice to see you. What's it like in Vietnam at the moment? What's the weather like? How's the existence like? Are you loving it?
It's great. The weather's good, not so bad. They've got through typhoon season pretty much, although Ho Chi Minh in the south doesn't tend to get any much extreme weather anyway. But yeah, it's a great city, very dynamic, lots of energy, lots of stuff to do. Really emerging, and obviously, as you know, Vietnam as a country in terms of its progress is dramatically increasing, and that's why I'm out here. Really, is to have a look at how we can look at utilizing some of the great resources they've got out here.
Well, I know you're a huge fan of Southeast Asia. It's good to have you here back in the Middle East. One foot here at least. Look, it's that sort of tech time of the year. I was saying just now, Nasser, here in the UAE, AI is kind of front and center, in particular the last couple of weeks, but obviously front and center overall. The buzz continues. But I wanted to just ask you briefly, where are we really? Just how clever is AI right now? Because that's where I want to get to with the conversation. You're writing a paper, and you sent a summary of it last week, and it's about resolving the sapient paradox. So we need to start with what the sapient paradox is, why it's important in terms of understanding thinking and intelligence as well, and then why we need to resolve that paradox. That's a very simple opening question, I don't think.
Yeah, good question. So the sapient paradox is something that's been around for a while, postulated by a guy called Gambler back in the late 90s. And that was why Homo sapiens in their current form, who have been around for something between 100,000 and 300,000 years, only really saw a dramatic increase in technological and civilizational progress within the last 10,000 years. Why was it that for that huge duration of millennia before that, there really hadn't been any progress at all? And that's basically the sapient paradox.
I feel, before we go on, I think I should probably offer a disclaimer here, to be honest with you. There's some fairly technical themes or technical ideas on the way here, but you put it very succinctly there. There are also some tricky phrases that we need to get to. Just that phrase, sapient paradox, is paradoxically hard to understand. So I'm going to try to ask questions as simply as possible. So the background there is sapient behavior paradox. How do we test for potential, and why is it that we've sped up so exponentially? We know that prehistoric people were genetically and I guess intellectually equivalent to us. Really, that's scientifically put forward. So why was there such a long gap between the emergence of genetically and anatomically modern humans and the development of complex behaviors is the heart of what we're trying to get to, isn't it?
Yeah. So basically, as you said, all the evidence shows that there hasn't been any significant change in brain capacity or cognitive ability in modern Homo sapiens since we we were around, 300,000, 100,000 years ago. And so the question is, why did it take us so long? As I said earlier, there's been a few different theories. There's been things like, not population density. There's been, perhaps the human brain did develop in ways that we weren't aware of, and a variety of other things as well. Now, my view on that is that there is actually a different explanation for it that is somewhat tied into the existing explanations, but is actually what I call knowledge density, as opposed to population densities. Now, what do I mean by knowledge density? Knowledge density is a system where you have elements of knowledge and how well those elements of knowledge are interconnected and relate to each other. So if you go back to, say, the hunter-gatherer societies where we first sort of formed as modern Homo sapiens, by the nature of the hunter-gatherer societies, they were disparate bands of roaming humans who each had their own, expertise of their local knowledge of their environment, and how to interact, and what they needed to know about that environment. And then, of course, then after a few 100,000 years of this, we coalesced into the agricultural societies. And it's when we became agricultural societies that we started inventing laws, regulations, rules to try and moderate, larger populations in a way that we hadn't had to worry about before. What this also meant was that we invented writing, we invented books, and in this way we were able to start consolidating knowledge into sort of much more condensed ways, as it were. And so bringing that knowledge together into these new societies basically meant that we were able to get the knowledge density that we were looking for, right? So now all of a sudden I know all of this stuff. I know how it all interrelates with each other. And it's when you reach a critical mass of knowledge density that you unlock what we call exponential cognitive yield. That's basically the ability for humans to start thinking beyond what they were able to think before. So basically, that's the idea. And if you look at the agricultural society, there was an explosion of innovation around, agricultural practices and this kind of thing. And as you look throughout history, you'll see like the industrial age, you'll see the information age, and then of course now the age of AI. These all coincide with periods in history where knowledge density hit a critical mass and we unlocked exponential cognitive yield and the ability to discover new things.
I'm glad I put the disclaimer in there, but I am still with you. Cognitive yield, critical mass. The thing is this, and I find this so interesting. I've read a little bit about the sapient paradox because you're coming on today, obviously, to join us. But so we emerged as a species somewhere between, 60 to 100,000, maybe 200,000 years ago. The behavior that's associated with modern humans began to emerge and accelerate around 10,000 years ago. And that's one of the great mysteries of human experience and human existence. So there's this explosion of human development that happened, but it happened without any change in the brain. And you mentioned there the brain and the lack of difference, really, the lack of movement from 10,000 years ago to today. So the human brain today is really not very different at all from 60,000 years ago. The difference is that it's the behavior that has changed.
Yeah, and the knowledge that we have that's changed, right? Our access to knowledge that's changed. So the way we learn is that, as you're a child and you start going to school and you start learning about the world around you. At first, what you're trying to learn, and even as an adult, you're trying to learn a new subject. As you're trying to learn, at first it won't click, right? Because you're starting to absorb knowledge of this new topic that you're trying to understand. AI being a perfect example, people are still trying to get their heads around what AI actually is and how it works. And so as you absorb this knowledge, you're making interconnections, what we call relationships between each of these knowledge elements. And once you get to a point where you understand, you've assimilated sufficient knowledge about that topic, and you understand the relationships between all of those knowledge elements, it clicks. All of a sudden you get it, right? You're like, ah, yes, now I understand. And it's at that point that your ability to understand the topic gets exponentially higher and higher. And it's what we call cognitive yield, right? Now, that is basically the exact same challenge that AI faces today. And that's why it's relevant to the AI discussion as well.
Okay, I'm with you. So the question is why the most significant developments in society and technology have all occurred in the past 10,000 years or so. That's also at the crux of this. And it's down to cognitive yield. So the agricultural, the scientific, as you've mentioned, the industrial, digital revolutions, the dawn of the world's faith-based systems, for example, any of the other symbolic concepts that separate Homo sapiens from other species. But what we know is that some of the complex behavior now associated with us humans took a long time to develop, even after the emergence in Africa of humans, who were fully kind of modern in the anatomical and genetic senses. But it's hard territory to pin down here. The question is coming, I promise. As yet, archaeologists and I guess anthropologists as well haven't reached consensus about when language first arose or when self-consciousness developed. We really don't know, do we?
That's such a good question. I mean, if we look at humans as we stand today, right, there are tests of consciousness that we can do. But there's one thing called the global and local oddball paradigm, and I'll explain what those actually are. The local oddball paradigm is basically where you take a person, a subject, whether asleep or unconscious, and you play a one-line series of, say, beeps. And those beeps are like deep, 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 and then you throw a random or deviant beep into there. Now, when you do that, even with a sleeping subject, you will get a brain reaction to it. So the subject, even though they're asleep, is aware of what happened there. Now, the global paradigm is a little bit more complex. In the global paradigm, basically, you play a series of these lines of beeps. So beep, 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 and then maybe 10 or 11 lines in, you suddenly throw a deviant sound in. So that requires much more complex brain reasoning and detection. And interestingly, whether you're asleep or unconscious, you cannot detect the global paradigm, oddball paradigm, only the local oddball paradigm, even if you're unconscious. Now, newborn babies, here's the interesting thing. For the first 6 months of their lives, they cannot detect the local oddball paradigm. So the most simple one line of beeps cannot be detected by newborn infants around about the first 6 months of their lives. That would suggest that they are not actually conscious. Why are they not conscious? Because they don't have sufficient amounts of neurons and relationships and synapses between those neurons to have activated consciousness and therefore acted cognitive yield and activated the ability to start absorbing and understanding knowledge and reasoning. So we do have modern day ways of checking it. But to go back to your question about human beings, the paradigm really, the sapient paradox really arose because, to all our knowledge, there was no problem with the capacity and ability of the brain right from the beginning. That's what separated us as Homo sapiens over every other hominid or human species. The difference was we just didn't have sufficient amount of knowledge to activate the ability of the brain.
So was there a trigger required? And is there a point at which a similar trigger will trigger artificial intelligence to make that jump to the next level?
Brilliant. It goes back to that critical mass that I was talking about. If you look at human evolution, when we became an agricultural society, it wasn't so much the fact that we had much more people now gathered in living together, as it were, in towns and villages and stuff. What it was the invention of writing and the ability to consolidate knowledge into centralized sort of facilities like libraries and things like that. Monasteries were at the forefront of that. And so now that human beings had access to knowledge that they didn't have access to before, they were now able to simply use the brain that they'd already got to start unlocking some of these innovations that really then dramatically increased the amount of progress that we saw. And again, it was the same when you look at the Enlightenment and you look at in the Industrial Revolution and you look at the Information Age, as I said earlier, they all coincided with periods in time where we had gathered sufficient density of knowledge to start unlocking new innovations. Now, to your question about AI, this, I believe, is the big challenge with AI today, and why the whole sapient paradox thing resonates with AI. If you look at AI as it stands today, AI is basically a pattern recognition system, right? You train it with lots of data, basically its ability to store examples of what it is that you want it to be able to generate, as it were. And then you feed information and it inputs into it, and it matches those inputs with the data that it already knows, and is able to then kind of provide you with a response. You've seen some of the seemingly very intelligent responses that come out of the likes of ChatGPT. The issue with that is it's not doing any form of real reasoning. It is literally just doing pattern recognition. So what that means is that if you take it, for example, into a corporate environment, it doesn't really understand the corporate environment. It doesn't understand the processes, the procedures, the operating model, the people, the things, the places. All it understands is these information points that you've trained it with and how they may match the inputs that they receive. That's not going to be the future. That cannot be the future, because we need to be in a world where we have AI that's able to reason, contextualize, understand, and provide specific outcomes that are an outcome of that reasoning that it is done. So that's, yes, absolutely why the sapient paradox is so relevant when it comes to the future of AI.
That's so interesting, because in almost every, I don't know, area of life, we're seeing AI now, and it's a servant to us. If you Google something now, you have your AI overview immediately. And I keep coming back to this example, but it's the best example I have, aside from ChatGPT and apps like that, that we all use day to day, and we are becoming accustomed to. We're understanding how to use them. But at the same time, it's very much a master-servant kind of relationship, it seems to me. And it has been traditionally. If you look at robots in science fiction movies over the years, or HAL, for example, in 2001, the idea behind HAL was always a little bit cold, a little bit beyond reach, a machine that was unable to contextualize. It was Spock with pure logic and a real difficulty in understanding the way things actually tend to work out. So from that to the leap where AI can contextualize and reason and be, almost, I use the verb be in this instance, it still seems a great leap to me.
Yeah, and current systems will not do the job. There's an increasing acceptance. If you look at some of the cutting edge researchers, I won't mention any names, who have already stated that large language models as they stand today, the neural network based large language models, are not the future, that we need to move to different architectures to really get to a point, to your point, that it's not a master-server relationship, i.e. it's not just literally pattern recognizing and responding to what we ask it. It is able to think and reason and contextualize in its own right. So how do you get to that point? You get to that point by giving the AI access to the knowledge that it requires to be able to and understand the relationships between that knowledge, so that it then is able to reason and contextualize it. The big challenge we have today is that all AIs, we centralize gigantic masses of information that we scrape off the internet, right? A lot of it's rubbish. And all of this huge volumes of information are consolidated into these gigantic data centers. And you've heard of all of the big AI companies trying to develop these huge new data centers out there, right? And then what's happening is, because you've got these gigantic volumes of sea of data, you have to have obviously gigantic algorithms and lots of compute and storage to be able to run your AI over the top of it. Now, in a world where that amount and volume of data is exponentially increasing, that will no longer be sustainable. We will no longer be in a position where we can continue to centralize huge volumes of data and run these gigantic neural networks over the top of it and use these vast amounts of computing power. So the question we need to ask ourselves is, how do we get away from that? What do we do? And I believe that the answer is what I call a global scale neural network. With a global scale neural network would, rather than centralize data, it would deploy the agents at the source of the data. And so the data would not need to go anywhere. The agents would be there locally installed at the source of the data. And the agents would only be allowed or authorized to extract the information or the knowledge that they require for the specific use case that you've developed those agents for. And these agents will effectively use a proprietary language to be able to talk to each other across the world. So if you, or if the AI is being given a task, or if it's got a purpose that it needs to fulfill, it knows which agents it needs to consult around the world, and all of these agents are collaborating with each other to be able to provide the contextualized reasoning and understanding based on the information that they have to hand. That, I believe, is a much more realistic view of what the future of artificial intelligence will look like.
It's a much more realistic view. It's an idealistic view as well, though, isn't it? The idea of a global neural network. It's one of those things, and I don't mean to, poo-poo the idea, Nasser, at all, because I think that's, it seems to me, a very intelligent way to move forwards. But, it's very hard to agree on what you get at, when you go shopping with your wife. That's personal experience only, I guess, or maybe it's not only personal experience, but you know what I mean. It's very hard to get people to agree on anything.
It is, and I think that's the beauty of the approach, is that if you look at effectively what these agents that you're deploying, they will be able to collaborate with each other, but each agent will only be authorized to access the other agents that it's allowed to access for whatever use case that you've deployed it for. So let's say, for example, you're doing network management of your company or your country. These agents would effectively be deployed at the source of each of your information points, and they would then collaborate with each other to look after, mend, update, repair the network in real time, all the time, as it were, as opposed to a human being having to do it. Now, the way this would happen, as I said, is that you wouldn't need to move any data. You would just allow these agents to collaborate with each other, and it's the collaboration of the agents together that effectively forms what I call a knowledge space, a knowledge hyperspace, actually. So this knowledge hyperspace doesn't exist. It's not a centralized data lake like you're seeing with current, AIs in these huge data centers. It's effectively a manifestation of a knowledge space that's created by the interaction of all of these agents. And then think about the fact that you can put any algorithm, any analytic over the top of this knowledge space. And now you can pretty much do whatever you want to in terms of your analytics, your AI, what use case you want your AI to focus on, as it were.
Okay, so let's assume benevolence here for a moment, that we're doing this for the betterment of humanity, and that we can move forwards as a race, as a human race. That I don't mean to be overly I guess cynical or pessimistic, but that seems really tricky. If you look just yesterday, data centers failing in the United States, AWS, Amazon Web Services having all these problems. The assumption of benevolence is a good thing, but there are always bad actors, would be my kind of response to you.
I agree with you, and I think that's the why the arc is so important for two things. One, privacy, what we call privacy at source.
Right.
Today, face it, we don't have privacy, right? All of our data is taken away, it's centralized, and lots of companies use that data to do whatever they need to do with it.
Mm.
In a local agent based, information based architecture, you can effectively program the agents to only be able to access your information that you want it to access, and only share the information that you want it to share. And that effectively means you now got privacy at source. And we know increasingly moving forward that privacy is going to be, a huge thing, because everything that we do is going to be online. Literally everything that we do is going to be online. So it's how do you guarantee that you have a global scale AI that can reason and contextualize and do pretty much anything you want it to do, but retain the privacy. And we do that by making sure that the agents are programmed in that way. Now, on your question around bad actors,
Yeah.
I think this is the other thing about why the architecture, I believe, is the way forward, is that um, when if you want to only allow certain agents to access this shared knowledge space, that's what you do basically, right? So let's say you have the UAE and the rest of the GCC countries who all want to collaborate on national defense, for example, and they want to be able to collaborate without moving their information, their data from their national boundaries, as it were. The architecture that I'm speaking about actually allows that, because the agents are not transferring data, they're just talking in this proprietary unhackable language with each other, and forming this manifestation of a knowledge space. That means that because you're only allowing your own agents to access this knowledge space, bad actors can't see it, they can't do anything, they can't hack it, they can't get in there because it doesn't exist. It's only the communication going on between the agents. And so I believe that's how we are going to solve the problem.
Okay. Let me ask you then, what steps do you need to take to create this global neural network so that your agents can communicate in this proprietary language, which the bad boys can't see, the bad guys can't get to? How do you? What steps do you need to put into place to bring this even into being, even though it doesn't really exist? I know you know what I mean, Nasser, where I'm going with the question.
Yes, so the technology actually exists already.
Okay.
The design of these agents, the proprietary communication protocol, the servers, the edge servers that these agents communicate with to then access into this shared knowledge space. All of this actually exists as we speak. I won't sort of go into, and plug anything here, but it exists. And so the question actually is not so much how do we invent the underlying technology. The question now is how do we build the specific agents and the specific analytics and the specific front end that we need for whatever use case it is that we want to develop. And so that's basically what we're looking to do now. We're saying, okay, right, we've got the underlying technology, the servers are there, the communication protocol is there, the underlying sort of the design of these agents and these analytic engines are all there. So now, what use case do we go for? What do we use as a proof of concept to show that this is now the future of global scale neural networks?
It's fascinating. The data centers are being built. I understand that. If take everything you've said into account, and intelligence, whether human or artificial, requires not only raw cognitive power, it needs a critical mass of structured knowledge to unlock its potential, and that's what we've really been talking about today, or started off talking about. For AI, does that mean understanding the point at which AI becomes truly clever, truly reasoned, not just a data regurgitator?
Yeah, it absolutely does.
Right.
Without knowledge density, you will never, whether it's a biological system or whether it's an artificial system, without sufficient knowledge density, you will never unlock true reasoning, reasoning capability based on contextualized knowledge and understanding of the subject that it is that you're looking at. As I said, whether it's biological or artificial. So the neural networks of today, just simply by the limitations of the vast amounts of data that they need to centralize and the huge compute power, we're not going to get to AGI, basically. That's what we're talking about, artificial general intelligence. We're not going to get there based on current architectures. However, as I said, if you are able to distribute your agents, you're able to distribute the compute power, therefore, you no longer have to centralize information or data. You can simply do it in a distributed way. You have far, far more of a chance of getting to that level of knowledge density that you need to unlock true reasoning, a truly reasoning AI. And you mentioned earlier about what it knows, and that's a really good point, because we're not talking here about conscious AI, right? That's a very different conversation.
Yeah.
We're talking about an AI that is able to reason in the way that human beings reason over knowledge, and how that knowledge interrelates. And that's what I believe is the future of AGI. We will not get there with current technologies.
Okay, and it kind of, I'm sat here thinking it kind of mirrors life. The old adage that, you know, you need to make mistakes to grow, you need to experience. AI, that's happening with AI now, isn't it? And I guess it kind of mirrors human development in some ways. It's just a whole lot faster. How far are we from AGI, as you term it, the AI that thinks, for want of a better verb to use, as far as we understand thinking at the moment, you know, reasoned AI? Are we as close as some people think we are? A few years, or is it longer?
If we're looking at current neural network-based architectures, GPT architectures that we're seeing,
Yeah.
I don't even know whether we're even going to get there, frankly, regardless of how long it takes. I think there needs to be a fundamental shift, as I was saying earlier, to distributed systems, distributed interconnected systems. If we shift to distributed interconnected systems, as I was mentioning earlier, I think within a decade we will see AGI.
Okay, 10 years. What are the implications when it comes to engineered intelligence systems? AI doesn't really have to concern itself with the sapient paradox. There's a paradox within this kind of conversations. AI can just keep moving forward at pace, assuming we take the path that you're espousing, I guess, as access to information allows, as, you know, concerted access allows. AI appetites are voracious. If you just keep feeding it, the sapient paradox doesn't matter, does it?
In that it does, only because simply feeding more data without training or allowing the AI to understand the relationship with this vast amount of data will never unlock the reasoning capability that we require. As I said, all you'll get is, I mean, we're seeing bigger and bigger neural nets. For example, I saw 4 billion parameter model being released not long ago. And the problem with that is that the more parameters, the bigger the neural network, the more you don't understand how it arrives at its answers. And frankly, the more randomness you put into the system, because it's just got too many parameters that it needs to have programmed, and therefore derive answers from. And as I said, I don't think that, for me, that's not the answer. You cannot just keep pumping data and throwing huge, bigger neural networks and more compute power, because that does not solve the problem of contextualization. And contextualization is what unlocks reasoning, and reasoning is what unlocks intelligence. So yes, I don't see that as the answer at all.
No, so if you just keep feeding the beast, that's the scary AI from science fiction, the scary robots that take over the world in science fiction.
Yeah.
Let me go on. Sorry.
Sorry, Tim, just on that point. And the thing is that it really depends what we want to use AI for, right? If we're saying that we want to try and build a single AGI, like a single collective global intelligence that will do everything for humanity, then that's one thing. If, however, we're saying, actually, you know what, we're going to go down the road of just building lots of miniature AIs that are going to be very specialized in their own specific particular type of role. Even if you go, which I think is more realistic based on current architectures, right? Based on current architectures, having these miniature AIs that specialize in little things you could do. However, the question is, if you want to move to AGI with lots of mini AIs, how do you get them to interrelate and interact and understand each other and contextualize amongst each other and therefore unlock that knowledge that they need to be able to work together? Again, you can't do it without massively centralizing lots of information, as I said earlier. So I don't see that as either way as the future at all.
My brain is starting to hurt, I have to say. I hadn't thought this would be such a tricky conversation, but it's so interesting. In the artificial intelligence mirrors human intelligence in so many different ways, and the interconnectedness and making that work from an artificial point of view is as tricky as it is from a human point of view. That's kind of the upshot of much of this conversation.
Yeah, massively it is. And as I was saying earlier, if we want to, everybody's worried about what AI might be capable of moving forward. And I've said this several times in the past that I don't believe that AI will ever become conscious. However, it doesn't really matter whether it's conscious or not. It really depends on what it's capable of, right? So whether it had an evil intent to do something is beside the point. The point is, what did it do? And I think if we're looking at centralized um, AIs, and we continue to go down this path of centralizing data, building these gigantic neural networks, then you are potentially building these AIs that could become out of control because they've got access to everything all the time in real time. But if we move to distributed systems and we have the ability to close off sources of information at will because it's a disparate architecture, that means we have far more control over what a future AGI would look like than we do with centralized architectures as we have today.
But you know what human beings are like, Nasser. We do like to be in control. And the hope with all of this would be, is the right person or body or government or organization, whatever, in control?
Yeah, exactly. Again, we need to look at the nature of distributed architecture. As I was saying, if you build it so that the agents are only allowed to access the parts of the knowledge space, i.e., the other agents that they're allowed to and authorized to talk to, then you are effectively saying that you don't have a central government or one central thing that's responsible or in charge. You're effectively saying, okay, this part of the knowledge space I'm segregating to this group of people, this government, this company, or you can open up access to different parts of the knowledge space depending on who you're talking about. So I agree with you. You cannot have a single centralized control point because we're too different as human beings for us ever for that to work. So yes, the architecture needs to be able to cater for that for sure.
It does, but we are still the variable, aren't we? This need to, I don't know, dominate or control among, certain people, I suppose. I don't really know where to go with this next. I'll be completely honest with you. Normally I have a question that pops into my head, but there is so much to consider here. Let me ask you this. What is it in you that, I mean, aside from this is your business, this is your interest, but what is it in you that drives you towards considering the sapient paradox? What was it that took you there? And by extension, takes you to the discussion that we're having today?
I have a fascination with humanity and also just concepts like reality and consciousness and why we're here, and obviously a realization as well that an AI-driven world is an inevitability. We are going to go there whether we like it or not. So we need to be able to ensure that we design an AI that's in a way that's going to be as aligned in its objectives as possible to us as human beings. And we are at that inflection point now where if we don't have these conversations, if we don't consider the things like privacy and control and things like that, that we're going to make a massive mess of it, basically. So my personal investment in this is one, how do we build an architecture that gives us control as human beings, and two, empowers everybody so that there is not one company or two companies or one country that's got all of the power when it comes to artificial intelligence. But how do we ensure that everybody, regardless of where they are, has the opportunity to participate in this brave new world? And that's why I believe that if we look at a distributed, localized collection of agents, individually controlled by people, that gives everybody the chance to participate in this new world.
How positive are you? Because, I've had lots of conversations about AI over the course of the last few months, particularly the last week or two, with, so much emphasis on tech here, with GITEX here in the UAE. How positive are you that we're taking the right steps in AI terms? Because everybody you speak to, if you speak to an app developer, they're building AI in somewhere. It's kind of vague and undefined, but there's AI there, and it's obviously, it's a selling point, it's a marketing point. There's no doubt about that. But how confident are you that we're moving forward in AI terms, in that it becomes a mutually beneficial relationship? The AI learns from us, and we gain positively from AI.
It's a good question. Probably not massively confident, only due to human nature. And the fact is that, human nature means that there's always going to be people who want to do something for their own benefit. If we look at some of the countries that have been trying to implement regulation, for example, a lot of that regulation has been pushed back on, for the fact that, well, if we limit ourselves with regulation, then we're going to lose the race. Basically, somebody else is going to take over, and they're going to do better, quicker, faster, better than we are.
Yeah.
And so no, we're gonna just do it our way. And so I think without regulation, it becomes very difficult to be able to police what everybody's doing. And honestly, even with regulation, the question is, will countries, companies, do what we think is best for humanity or not? But as I said, I genuinely don't think the current generation of AI is a sustainable model for the future anyway. So that gives us hope. It means that we've got the opportunity to do it again with a different type of architecture that will take lessons and learnings from what we've already done with the current generation, but we'll move to a new architecture. So the positive side is I still believe that there's hope ahead of us for sure.
It's nice to see you smiling, but I mean, it does bring me back to, the likes of the real kind of AI, I don't know, app, social media innovators, the Sam Altmans, the Zuckerbergs, those kinds of people. These were young guys in a dorm room in almost all instances, actually, looking for the next great thing. And you would imagine that maybe AI could evolve. Is that the right verb to use? Probably not, but you know what I mean, in a similar way.
Well, there was two red lines that when in the early days of AI, there was two red lines that were drawn up. One was when we hit a point where AI is able to self-improve, and the other was when AI would be able to self-replicate. Now, there's a startup out of Japan, a couple of former Google engineers who have been doing some work around self-improving AI, and they've done some pretty interesting, let's say, work already. In that, the biggest challenge when it came to self-improving AI was how does the AI improve itself without destroying itself or potentially destroying itself, because it's changed its code and it messes it up. right? Well, what these guys have innovated is that they've given the ability for the AI to form replicas of itself, um, code those replicas, benchmark those replicas against global AI standards for learning, contextualization, reasoning, etc., and then keep the copies that it believed were going to be potential for it to evolve itself, disregard those that weren't. And so it was effectively building like a family tree almost of replicas itself in storage, so that it would kind of jump between each of those replicas as it effectively self-evolved. Now, the technology is still in its infancy, but that, to answer your question, is both what I would say alarming and very interesting as well. So that's red line number one. And red line number two is the ability for AI to self-replicate, and that's already been proven in a test that was done out of a university. Where they were able to take two mid-range large language models and set up an environment where they gave it an agentic capability to access all of the various resources on the computer that it was sat on, and challenged to replicate itself. And it was able to successfully do that between 50 and 90% of the time. Not only do that, but able to sense when a shutdown command was coming, and in the microsecond before it was shut down, replicate itself and tell its replica to replicate itself, and so on and so forth.
Wow.
So again, both alarming and very cool. But yeah, we're not far away from those red lines becoming a reality out there.
Let's keep red lines in mind for a couple of moments, but let me ask you, I guess this is more a philosophical question than anything. What do you think took us so long? Why did humans spend 50,000 years or more in seemingly uneventful prehistory, hunter-gatherers living the exact same way across what was clearly thousands of generations, before this trajectory, this takeoff that took us from cave paintings to self-driving cars? I mean, in comparative terms, that's the blink of an eye, isn't it? Let's face it. And in AI terms, with the speed of AI moving towards those red lines, perhaps or perhaps not. But what took us so long?
For me, it was combination of environmental factors and population factors. So, for millennia, there was sufficient flora and fauna to sustain the hunter-gatherer societies that were prevalent at the time. But there came a point due to climate change and other environmental factors, population extinction, etc., that by necessity human beings had to start thinking about coming together, and that's where agricultural societies came up, and fundamentally at that point of agricultural societies, where for the first time in human history we had large populations of people who now had to interact, work, live, and play with each other, and so you had to, as I said, develop norms, rules, laws, etc. And that's those laws, of course, you had to be encoded. So you invented writing, you invented books. And once you'd got both the size of the population and the amount of written knowledge within that population, that's all of a sudden the point where we unlocked the huge innovation curve that we're seeing in the last 10,000 years.
And we're now learning from AI while we're teaching AI, aren't we?
Well, and this is the challenge. I mean, both the challenge and the opportunity is that AI, the difference between AI and humans is that we have far more computing power than the average machine, right? The average, say, laptop. We have millions of times more computing power. I believe that there's a weather forecasting supercomputer in the UK, which is the minimum model that has the same processing power as the human brain. So you've got to be right at the supercomputing level.
Yeah.
The problem for human beings is that although we've got these massive computing power, our bandwidth is constrained, i.e. our ability to input and output information. So we are limited to 110, 150 words per minute that we can both absorb and we can output as well. Whereas if you look at machines, even though they've got way less computing power than we have, their bandwidth is exponentially higher than ours is. And so what that means is that they can take information points and be able to output the analysis of those information points far quicker than we can because of our limited ability to communicate. And so if you go back to the question that you asked, that's why it's very exciting when you look at the ability of AI to not just accelerate, but super accelerate the progress that we've seen over the last 10,000 years. I think we're going to see a doubling or tripling of the civilizational progress over the next few decades.
And we all have to try and keep up. Do you know what? One of the things I really like about talking to you, Nasser, is marveling at the input and output speeds that you demonstrate on a regular basis. It's remarkable. I always really like talking to you.
Yeah, same. No, I always enjoy talking to you, Tim, for sure. And like I said, for me, this is all very fascinating because there's nothing more fundamental to human the future of humanity than technology. You're seeing, for example, robots. I don't know if you saw that company Figure AI, who just released their version 3 of their home robot.
I
mean,
did.
it's phenomenal.
It's amazing.
Phenomenal. Yeah, and the leaps and bounds just within the last 2 years that we've seen in the robotic space, and of course these robots are now being installed with mini neural networks of their own. So once we've solved the power problem, i.e., how do we keep these things operating for a sustained period of time, we are going to be seeing populations of intelligent robots. So that whole iRobot future. Okay, maybe that was a wrong example because that was a bit dystopian. But we'll see with that future is not far off, where we have intelligent machines working with us day to day, day in, day out.
You're quite right. And that example that you mentioned there is remarkable. And it is a very positive example as well, with the AI, with the robot doing the, loading the dishwasher and doing the vacuuming and all the things that probably we would like to offer to somebody else. Nasser Bostan, founder of Simulacra X, joining us from Vietnam on Mira Business FM. Thank you, Nasser.
Thank you. Thanks, Tim. See you later.
Great to talk to you. The news is next.